Okay, so these are the problems out of the book that I'm doing first. So the first one asks you to find all of these things given this equation. So this is the equation of a parabola. The easiest way to do this is to convert it into vertex form. And so I'm going to complete the square with the first part. The 15 we're going to leave alone. So I'm going to have x squared minus 8x. So half of 8 is 4. 4 squared is 16. So I'm going to add the 16 on, and I'm also going to subtract 16. So that way I'm really adding nothing there. So I can do that. Now the first part that we just did, x squared minus 8x plus 16. So now if I take that, that will factor to be x minus 4 squared. And then 15 minus 16 is negative 1. So that's my equation in vertex form. So because this is an x squared that is positive out here, I know that it opens up. The vertex is at 4, negative 1. So remember, it's always backwards of whatever's inside of here. The x-intercepts, it's probably easier to find the x-intercepts. Well, I don't know if it's easier. Either one of those use, and you just put them equal to 0. So I'm going to take x minus 4 quantity squared minus 1 equals 0. So then I'm just going to add 1 to each side. I have x minus 4 squared equals 1. And so now to get rid of the squared, I'm going to square root. So x minus 4 equals positive 1, and x minus 4 equals negative 1. Remember, when you put the square root, there needs to be a plus and minus. So now I just add 4 to each of those. So I get that my x-intercepts are 5 and x equals 3. So my x-intercepts 5, 0 and 3, 0. My y-intercept is definitely easier to use. This one, you just plug 0 in for these x's, and we get that it's 15. So when x is 0, y is 15. You could also plug it in here, 0 minus 4 squared. So negative 4 squared is 16, minus 1 makes 15. So you get the same thing. So then you're supposed to sketch it. So you draw your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The x-intercepts are at 5 and 3. 1, 2, 3, 4, 5. So 3 and 5. My vertex is at 4, negative 1. So I know it does something of this nature. Axis of symmetry, that would be this line right down the middle. And that's going to be the same as your x-coordinate of the vertex. So that's x equals 4. Because it opens upwards, this is a minimum. And that occurs where the vertex is. So there's a minimum at 4, negative 1. The domain, this thing goes left and right forever. So the left is negative infinity, right is positive infinity. The range, how far down does it go? Well, the lowest point is negative 1. And then it goes up forever. So that's question 2 out of the book. Question 5. So this one's a little bit more challenging. It says you have 180 yards of fencing to cover this much area. So that's the perimeter. So I know that 2x's plus y equals 180. Okay. Now the next thing is I need to figure out the area. Area is x times y because it's length times width, so that's the area. And we want to maximize the area. So I'm going to solve this perimeter for y. So I have y equals negative 2x plus 180. So now I'm going to take that answer and I'm going to plug that in place of the y in the area. So I'm going to replace that y with that. So I'm going to have x times negative 2x plus 180. So what I have is negative 2x squared plus 180x. So when we want to maximize it, if I were to draw the equation of this, it's going to be a parabola. But the maximum occurs right here. That's the maximum value. Depending on whatever the x is, that'll give us the maximum value for this. And so, knowing that, I can rewrite this so that it is in vertex form. So I'm going to pull out a -2 from each of those. So it's like I divided them each by 2. So x squared minus 90x. So half of 90 is 45. So I go to my calculator because we need to square it. So 45 squared is 2025. So inside of here I have -2x squared minus 90x. I'm going to add 2025. I'm going to subtract 2025 inside of here. And I'm going to only look at this first part right here to factor it. Okay, so that first part factors to become x minus 45 squared. But realize that was just this part. Okay, so I still have -2 times that. So negative times negative makes a positive. And then I'm just going to double that, so that's 4050. So my vertex is 45, 4050. So that's meaning that the x is my vertex. That's the x coordinate. So this x coordinate is 45 and 45. Which means this y has to be 90 because there's 180 yards of fencing. So 45 plus 45 is 90, plus 90 more makes 180. Now, what dimensions would maximize the area? So we've given the dimensions, and this gives us the maximum area. So if you were to multiply 45 times 90, you would actually get 4050. Just to show you that, 45 times 90 is 4050. So anyways, that's how you do question number 5. So the dimensions are 45 by 90, and the area is 4050. Okay, it says to use the remainder theorem. What that's really asking you to do is do synthetic division. Remember, this is saying that x equals -2. If I plug in -2 for all of these, what's my answer going to be? Well, you can use the remainder theorem in synthetic division. We have to put a 0 right here because remember, that's x to the 4th. X cubed is 0. X squared is 2, -4, and 1. This remainder, when we do all of this, is the answer we would get if we were to plug -2 in for all of these x's. So if I were to type this in the calculator and tell it to solve all of that, so 3 times -2 to the 4th plus 2 times -2 squared minus 4 times -2 plus 1. I get that it's 65. So when x equals -2, I get 65. So if I were to do synthetic division, I should get the same thing. -2 times 3 is -6. 0 plus -6 is -6. -2 times -6 is 12. 12 plus 2 is 14. -2 times 14 is -28. -28 plus -4 is -32. -2 times -32 is a positive 64. Plus 1 makes 65. So that's what it says when you're doing the remainder theorem to evaluate this. This is saying when x equals -2, what does y equal? Well, y equals 65. And you can get that answer both ways that I showed you. Plug it in the calculator, or you can do synthetic division. So on this problem, it's kind of similar to the last one. It says, determine if the given number c is a 0 of the polynomial. So we're going to do synthetic division again, And if the answer is 0 at the end, we know that it is a 0. So c equals 2. So now my coefficients are 3, 13, 2, 52, and negative 40. So again, remember that's my x to the fourth, x cubed, x squared, x. You have to have all of them covered. So that's just my number term right there. So the 3 goes down. 3 times 2 is 6. 13 plus 6 is 19. 2 times 19 is 38. 38 plus 2 is 40. 40 times 2 is 80. It's not looking good. 132 times 2 is 264. Minus that is 224. So is that a 0? That would definitely be no, because that's not a 0 at the end. So now I do the same problem, except for on the outside it's a 2/3. So 3, 13, 2, 52, negative 40. So the 3 comes down. 2/3 of 3 is 2. 13 plus 2 is 15. 15 divided by 3 is 5, times the 2 is 10. 10 plus 2 is 12. 12 divided by 3 is 4, times 2 is 8. 52 plus 8 is 60. 60 divided by 3 is 20, times 2 is 40. So I get that that's a 0. So C is a 0. On this case, with it being 2/3, C equals 2. That is not a 0. Okay, question number 40 asks you to answer all of these questions. So it says as x approaches negative infinity. So in other words, what happens as x goes this way forever? Well, as x goes this way forever, my y value gets extremely close to this line, which is negative 3. So my y value approaches negative 3. Now it says as x approaches negative 2 from the left. That's what the little minus up here means, is I'm coming in from the left. So if I start walking along this line, I'm coming in from the left. I'm getting really close to negative 2. But as I get closer and closer to negative 2, this value keeps skyrocketing upwards, which means that means the y value is going up to infinity. Now this one says I approach negative 2 from the right side. So here it is. I'm walking along. I hit my graph. I start walking on my graph. I'm getting closer and closer to negative 2, but as I get closer and closer to negative 2, this guy rockets downwards. So y approaches negative infinity. And finally it says as x approaches positive infinity, in other words, I'm going out this way. So I'm going out this way on my graph. I get really, really, really close to this number, which is negative 3. Now, when is this thing increasing? So if I'm a little hiker hiking along this path, and this is a mountain, it increases all the way along here. It also increases all the way along here. It never decreases. So decreasing is easy, none. But it increases from negative infinity to negative 2. Remember, you only use the x coordinates. So between way out here and negative 2, it increases, along with this point over here, which is negative 2, all the way to infinity. Remember, these little parentheses means I get really close to negative 2, but I never actually touch it. The domain is exactly the same thing as what it's increasing over. Okay, the domain is saying which x's are used. Well, this thing goes to the left forever. Over here it goes to the right forever. And we only don't have a point when x equals negative 2. The range. Well, this goes up forever and this goes down forever. The only part we don't have a y value is this y value right here, which is negative 3. So the range is negative infinity to negative 3, along with negative 3 to infinity. My vertical asymptote, that's the one that goes up and down. That's x equals negative 2. My horizontal asymptote is the one going side to side, so that's y equals negative 3. So on problem number 46, it asks you to find all the asymptotes. First thing I'm going to look at is that this power is 3, this power is 2. So this one on top is exactly one bigger. So if the top is bigger than the bottom, there's not a horizontal asymptote. But because it's exactly one bigger, there is a slant asymptote, and I will find it by doing long division. So inside here, we put our 2x cubed minus our x squared minus 6x plus 7. So now we do the Long division, what times x squared makes 2x cubed? That's 2x. The important part is you have to remember to distribute that to both pieces. So 2x times x squared is 2x cubed. 2x times negative 3 is negative 6x. So realistically, that needs to go over here because that's the same power on the variable. Remember now, with long division, we change the sign because we always subtract. So that goes away, and negative 6x and positive 6x, those go away. So I have negative x squared plus 7. So what times x squared makes negative x squared? That's negative 1. So negative 1 times x squared is negative x squared. Negative 1 times negative 3 is positive 3. Change the signs. Those go away. 7 minus 3 is 4. That's my remainder. I could care less about the remainder. All that I care about is this part up here for my slant asymptote, so it's y equals 2x minus 1. So the only other one you have left is the vertical asymptote. You just take the denominator, put equal to 0, and solve for x. So now you have x squared equals 3. To get rid of the squared, you square root. So x equals plus or minus the square root of 3. So those are your vertical asymptotes. So the last problems on this, you're supposed to solve these inequalities. Remember, to solve these, you've got to make them equal to 0 and solve it like it were an equal problem. So I can't do that yet because it's 18. So I need to minus the 18 over. So now I have t parentheses t minus 3 minus 18 equals 0. Well, that doesn't look very good. But if you think about it, if I distribute, I now get t squared minus 3t minus 18. That looks more familiar with the problems you know how to do. So now you can factor that to t and t minus 6 plus 3. So now I set each of those equal to 0. And remember, these are just going to give you your critical values. So t equals 6 and t equals negative 3. So those are your critical values, and then you plug those onto a number line, so negative 3 and 6. And then you choose test numbers. So negative 4, that's to the left of there. Between negative 3 and 6 is 0. Bigger than 6 is 7. So those are my test numbers, and we're going to take those test numbers and plug those back into the original equation. So negative 4, negative 4. So negative 4 times negative 7, negative times negative is a positive, is 28, which is greater than or equal to 18, so that worked. So now I plug in 0. 0 is nice. 0 times anything is 0, so it doesn't matter what's in here. Is 0 greater than 18? No, it's not. So 7 minus 3 is 4. 7 times 4 is 28. 28 is still bigger than 18. It hasn't changed. So these are the two areas that work. Because it had an equal underneath this greater than, we can use brackets. So we're going to go from negative infinity to negative 3, along with bracket 6 to positive infinity. 65 is the same kind of thing, but remember, your critical numbers are also the vertical asymptotes, or the parts that x cannot equal, so it would make it go to 0 on the bottom. So I put that equal to 0, and I get that x cannot equal 2. So that's one of my critical numbers, and x cannot equal 0 on this either, because they would make the denominator be 0, which causes all sorts of chaos. So I plug those on here. I know that there's going to be one at 2 and one at 0. And who knows what the other one is. So now I put an equal sign in here and solve this as though it were an equal. So I'm just going to cross multiply. 3 times x is 3x equals negative 2. Make sure you distribute that. Negative 2x plus 4. So I add the 2x, add the 2x. 5x equals 4. Divide it by 5. And x equals 4/5. So I'm going to erase this down here. Draw me a new number line. So I have 0, I have 4/5, and I have 2. So test numbers would be negative 1. 4/5 would be 1/2. Between 0 and 4/5. Between 4/5 and 2 is 1. Greater than 2 is 3. So now we've got to plug in all those numbers and find out which ones work and what happens to them. So I plug in negative 1. 3 divided by negative 3 makes a negative 1. Is that less than a negative divided by negative is a positive? So is that less than 2? Not last I checked. Oh, yes, it is. Good thing you guys are thinking on that. So anyways, negative 1 is less than 2. That works. Now I plug in 1/2. 1/2 minus 2 is going to make negative 1 1/2. So that's negative 3/2. So 3 divided by 3/2 is the same as multiplying by its reciprocal. So that's negative 2. Is that less than, I'm plugging in 1/2 up here for x. So negative 2 times 2 is negative 4. Which one's further left? Negative 4 is further left, so negative 2 is not less than negative 4. Now I plug 1 in. 1 minus 2 is negative 1, so I get negative 3. Negative 2 divided by 1 is 2. So is negative 3 less than negative 2? Yes, because it's further left. Now I plug 3 in. 3 minus 2 is 1, so I get 3 over 1. Is that less than negative 2/3? No, because negative 2/3 is further left, so that didn't work. So I know that it cannot equal 0, and this is an easy one because it's not greater than or equal to, so all of these have to be parentheses. So negative infinity to 0, along with 4/5 to 2. So those are my answers. Finish up the book problems. It says D is directly proportional to C and inversely proportional to the square of x. So D equals some constant of proportionality to C and inversely proportional to the square of x. So that's my equation. It says D equals 1.8 when C equals 3 and x equals 2. So I plug it in. 2 squared is 4. So I have 1.8 equals K times 3 over 4. So to get rid of that, I multiply by 4/3. And what I do to one side, I must also do to the other. So 18 divided by 3 is 6. So 4 times 0.6 is 24. 4 times 6 is 24. Then the decimal, so 2.4. You can use your calculator. I'm trying to hurry. So anyways, that's how that works. Now, number 74, it says the weight of a ball varies directly as the cube of the radius. So that means the weight varies directly as the radius cubed. A ball with a radius of 3 equals 3.24 pounds. So to solve for K, 3 cubed is 27, so I divide each side by 27. So I go to my calculator, 3.24 divided by 27. I get that K equals 0.12. So K equals 0.12. Now it says how much with a radius of 5. So how much will a ball with a radius of 5 equal? So the weight equals 0.12 times 5 cubed. So I come back to my calculator. I'm going to take 0.12 times it by 5 cubed. And I get that the ball weighs 15 pounds. So that's the book problems.